In this tutorial, we will look at adding obstacles to our PyGame template. These obstacles will prevent the player from moving through them and could be applied also to the non-player characters. Here's an example screenshot showing that we could have a policeman, and he has some crates that he's not able to move through, and these zombies would also be blocked by the crates. So our action's taking place perhaps in a warehouse. I will be using a crate image that I've got from TurboSquid, and this has been uploaded to the Birkdale Teams REPL for you to be able to use. You could of course use your own graphics. So a few things before we get started. In this version of our game, our check collide code needs to return 0 if it doesn't collide with something, or some number if it does collide with something. And it's important that our code is not just affecting the score directly, but is returning a value when it's called. We're also going to set up some initial information in our REPL. So I'm coming here to Birkdale's Teams, and I'm going to go down to the Team Projects, all the way down to number 9, Customize Core for your own game. When you click on this, it should load a new fork of the REPL for you. Because I've created this, I will have to fork this manually. So I'm going to come up here, and I'm going to choose to fork this. So this makes my separate version that will not interfere with your basic template. So I'm going to come to Files and look at our main.py. And the first thing we need to check here is that our check collide is returning some number. It's based on how fast you run into something. But if you're not hitting anything, it's returning 0. And that's exactly what we're looking for. Okay, so let's have a look at what we're going to add to this then. We're going to create some obstacles, so we're going to give them a default size. This was originally created for a larger screen, so I might modify that and bring it down a little bit. We're then going to load a crate graphic, which is supplied online for you. We're going to scale the crate to match our obstacle size, and then we're going to create a little grid of placement for these objects. Now I find the best way to plan this is maybe with a spreadsheet. So you can see that I've put a crate here at 1, 1. And then another one at 2, 1. So we're doing an X coordinate and then a Y coordinate down the way. So 1, 1 and 2, 1 are this box and this box. Then I've got one at 4 along and 4 down, 4 along and 5 down, 4 along and 6 down. So we can just lay out obstacles to make our game environment here. And you can see I've got a list of these coordinates. Notice each one is put inside a square bracket and a comma between, and the whole set of obstacles is inside another set of square brackets. So let's add these to our code. We're going to start off. I'm just going to come down here to above my main game loop, and I'm going to say obstacle size equals, now instead of 50, I'm going to maybe go for 30 here. Maybe 32, because I can see that my enemy size is 64, so half of an enemy size might be a good size to work with. Okay, and then I'm going to say that crate equals PyGame dot image dot load. And then I want to load the crate object, which is called crate.jpg. So you can see that up here in the file section, I have crate.jpg ready to go. Now, having loaded that in, I want to make a version of it that's a good size for the game. So I'm going to take it again, and I'm going to say it's PyGame dot transform.scale. And scale wants to have a surface, and then a size, and then a destination surface. So I'm going to scale it onto itself, create, and then I'm going to give it inside square brackets a pair of a width and a height. So they are going to both be obstacle size, comma, obstacle size. So that's me set up being able to draw a crate, but I then want to have a list of all the different positions. So obstacles equals, I make my square brackets to hold the entire list, and then I make each one as a pair of coordinates. So 1, 1, and then between those I put a comma, and then another square brackets, 1, 2, and then another comma, and then more square brackets, 4, 4, 4, 5, and I've forgotten to put brackets around that one, so that would have caused a problem. And 4, 6, and then I need to make sure that I've closed. I'll just try out a few of these at the moment. I can always add more if I'm happy that things are working out. So I have a crate image loaded, I've made it a decent size, and I now have the position of a few different crates that I would like to draw onto the screen. So the next thing I want to do is to then draw these obstacles at the appropriate place. So I'm going to go to my drawing section of my code, and I'm going to create a for loop that draws each obstacle. Probably I want to draw them before I draw anything else like the zombies or the cop. So I'm blitting them to the screen, and I'm using their coordinates scaled up by multiplying by obstacle size. So I'm going to scroll down here. There's all my game logic inside my while loop. Notice I have little comments here. So for example, line 94, update screen to show all changes. That suggests that below this section is where my drawing's happening. So I'm going to come down here after I've done screen fill black, and I'm going to move into the same level as that. I'm going to say for block in obstacles. So each obstacle is going to be treated as a block, and then I want to screen.blit. So what do I want to blit? I want to blit the crate. And where do I want to blit it? Well, I'm going to give it some square brackets, and then I'm going to say block 0, so that's its x coordinate, and I'm going to multiply that by obstacle size, and then comma, and block 1 is its y coordinate, and I'm going to multiply that by obstacle size. So if I run my code now, hoping we're not going to get any errors, and you can indeed see that if I click into here, I do have crates being drawn. Now at the moment they're having absolutely no effect because they're just drawing to the screen. They're not actually part of the game logic. So that's obviously the next thing that we have to do. But notice 1, 1 and 2, 1, and then 4, 4, 4, 5, 4, 6. So the coordinates seem to be working out nicely. So having drawn my list of obstacles, I now need to do something about stopping the player if the player tries to bounce into them. So I'm going to comment out this x equals x plus x speed, y equals y plus y speed, get rid of those, and I'm going to put a new set of code in here that checks whether if I did use that speed, it would end up being on top of an obstacle. So we're going to come here, and we can see that our x equals x plus x speed here is going to be commented. Y equals y plus y speed there is going to be commented. And then I'm going to come in here just below game logic, and we're going to say, so path, blocked equals false. So let's assume that I'm not blocking the path to start with. I said move blocked here, path blocked, it's just going to be the same. I'm now going to try a new x and new y coordinate as where I might end up. So new x equals x plus x speed, and new y equals y plus y speed. So this is going to be test points that I'm trying to look at. And now I need to look at each block in turn and see whether I have banged into it. So I'm going to say for possible block in obstacles. So each of these may be something that I'm about to trip over or bounce into. Now the easy way for me to get the check collision bit will just be to copy and paste it from down here. So I'm going to reuse this bit here, and I'm going to say bumped equals, and I want to check not against x and y, but against new x and new y. And I don't want to change it, check against the monsters, because I don't have monsters at this point. What I've got is possible blocks. So possible block 0 and possible block 1. And we're going to look at them as obstacle size for their height and width. Okay, now one thing that would cause a problem here, block 0 is the x coordinate and block 1 is the y coordinate, but that's for our grid. So remember that our grid is a blocky version of the entire screen. So I need to make sure to translate that by multiplying the x and y by the obstacle size. So here it's going to be possible block 0 times obstacle size, and then possible block 1 times obstacle size. Okay, so for each block I see whether I have bumped into them. I'll just close this up so that we can see that code a bit better. There we go. Now, what I want to do is, if I have bumped into a block, I'm going to say if bumped is greater than 0. Now remember that 0 means we didn't bump into anything, and any other score means that we have collided with it at some kind of speed. So if bumped is greater than 0, then path blocked equals true. So we started off with path blocked being false, and now we are setting it to true if we bumped into any obstacle at all.